Hi, I'm Dale Hemla. I'm an electrical engineer with UPPCO. My role is a distribution planning engineer. I'm a Michigan Tech graduate. I've got 25 years in industry that encapsulates iron, steel, and chemicals, and now the utilities. My main role here is to make sure the lights stay on and reliably and safely, and then and make sure everybody's safe to work around the power and live around the power that comes to your house. Some of the things I enjoy as an engineer, basically getting to work outside. A lot of times people are focused inside of an office, where probably 25% of my job is out in the field working with others. You get storms coming in and it presents very challenging issues that you run into, different problems, different ways to fix it. And then the end goal is to make it safe and reliable, even with all these storms coming through. The other thing I like about my job is to communicate with other engineers, other community members in the community, and then linemen and various other people in the company. In my role, I deal with those people directly. One of the main things that an electrical engineer uses is day to day is a computer. The first program we're going to look at is Autocad. That's where we design and lay out the circuits that are on our system. And that's what I've got up here. This is a physical and electrical representation of what's out in the field, and it's condensed to make it easy for an engineer to look at, or anybody as far as a lineman or any other technicians to see our whole system condensed onto one page, and it's easy for troubleshooting in event of a storm. Another tool that's on the computer that the engineers use is the SIME. In this case, it's a power simulation software that we use to simulate the network and test out conductor sizes, fuses, whatever you may, and enables us to add a portion of the circuit to add on to the circuit and test out if the circuit's going to respond the way we want. And also for coordination of between the substation and all the downstream devices to make sure in the event of a storm or a tree down on the line, it's not going to knock out all the power for that particular line, and isolate the storm as much as possible. One of the parts I do is a load allocation and a load flow. And what this does, it allows me to see where the load is on our system as far as the customers, and anywhere on the system I can see what the voltage will be in an event of a loading that I've set up and what kind of current on each phase will be. And this tells me if we're going to be in overload condition or any issues with the wire or conductor up in the air. So another thing I have in my office is prints that are readily available, printed out so I can reference them if in need of power outage. I can reference the whole system without having a computer on or need for power. So I reference these throughout our system from Escanaba all the way to Houghton. Next thing in my office is you're going to see a lot of parts. I keep a good inventory of parts that I'm evaluating for basically engineering reasons or standard reasons. Either we find obsolescent parts or new standards we got to put together. And I always like to get a part, what we're going to be looking at, in my hands to review. Same with here with these parts. We're looking at different reasons we're using this part, this part. At least I get them in my hands, look at them, and also get it to the linemen to see what they think and what kind of ideas they have. So another tool I use regularly on the computer is the Scada System. It basically gives me a live action viewing of what's happening at each one of our substations in UPPCO. I can see if a breaker is open or closed, how much current is passing through or power passing through a transformer or a breaker, and in an event of a storm I can see which breakers are open and closed and to see what's going on. I also use that as a tool to pull data after a year or so of running. I can see what kind of data as far as current voltages are going through our system to better analyze our data as far as sizing a system in the future for future use. This is an example of the cable going to your house. It's the two hot conductors are ones with voltage there have covers on them, and then the neutral is not covered. It's as an engineer you decide what size cable you serve the house with, and it's all based on how much load the customer is going to use. So as an engineer you're going to design what size cable is properly sized for the house. So this is a transformer. This is something that takes our distribution voltages that we distribute throughout the area down to on these terminals down to 240 volts. As an engineer, we design where these go, and as far as our specification, we design what kind of oil's in here, what size of transformer we use, what size bushing we use. So we really design from the top and bottom to the customer what they use and they don't use on these. This is just an example of an overhead that's probably outside of your house on a pole. So this is a pad mount transformer, so this is going to be on the ground versus our previous transformer that was up in the air. It does the exact same thing. We're taking our distribution voltage down to the customer 240 volt if that's what they need. And in this case we've had underground feed, so we've got cable running to this on the high side and then bringing cable to the customer on the low side. If you look at it from afar, it really just looks like a green box, but everything's on the inside as far as what it does, bringing the voltage down to the customer level. There again, as an engineer, we decide, you know, the standard on this transformer, what we get, and then if we decide to put it underground or overhead, there's a certain cost for that, and understanding the reasons to do either. So this is an example of a distribution circuit that we're feeding a business, and in this one, as an engineer, you basically figure out where is this transformer going to go in the system, what size cable is going to be on the distribution circuit, how big a wire and how much current's going to be needed to be drawn, and then even down to the design of the pole, the specification on it. You know, what type of pole material you're going to use. Is it pine or cedar or other materials? So as an engineer, you basically decide what's going to be in that pole itself. So you've got several different factors that you're looking at as specifying this whole circuit, besides laying it out as an engineer. So this is our meter farm. This is where we test out the meters and make sure they're working right. On your house, you've got the same meter, and this is what we measure how much power we're using at your house. So hopefully this gives you some insight of what an electrical engineer does at a utility. You know, from my work encompasses keeping the lights on and making sure everybody's safe, both in the public and our linemen as well. You know, it's a very rewarding job and very challenging at times, and a lot of different specifications that are out there, and it's always something new. If you're interested in STEM, especially if you like math and you're good at it, I think that'd be something you want to consider for a career in electrical engineering. I thank you for your time. Appreciate it.